Hello. I appreciate being given the opportunity here to be able to present this paper, which spots the light on the problem of increase of children's death due to them being in the front seat of the vehicle. Our paper, our paper called real-time detection of children in the front seat of a car using deep learning algorithms. This was done by Athirah Mohammad Alsughayyir under supervision Dr. Saleh Alluhaidan, presented by me, Walda. Our agendas for today are benefits of child safety, seat literature review, and then problem statement and motivation. And then we have objectives, system components, and car and person detection, which include face detection and face classification and data collection for face classification. Can you hear me clearly? So what brought our attention to this problem is the percentage increase of children death in Saudi Arabia. Statistics shows that 40% from the registered death are from traffic accidents, and 50% is because they are not seated properly. Which takes us to importance of child safety in cars, and that's why we need to take a protective approach for this problem. We also kept in mind challenge of detecting children in the front seat, which is why we saw the need for an automated system that can find children in the front seat. Benefits of child safety seats. Child safety seats can reduce fatalities by 71 for infants and 54% for toddlers, and 45% belt positioning boosters seats lower the risk of injury to children aged 4 to 8 years by compared with the use of seat belts alone. A study by Harvard in 2018 introduced the deep learning framework specifically designed for a child detection in cars. Their model based on VGG16 only, based on object detection only, and detect object inside the car, not on the front seat of the car. If there was a doll in a car, it would detect it as a child. Our problem statement and motivation was lack of effective and efficient methods for detecting children in the front seat, and the motivations is enhance child safety and reduce the risk of injuries. Automate real time. It helps to implement traffic flows with a lower error rate. Going to the objectives, develop an all-based deep learning algorithm for detecting children in the front seat. Specific objectives, develop a robust algorithm using VGG16 and CNN for face classification. Implement object detection to focus on person inside the car. create a system for real-time monitoring and violation detection. Our system components, which is the most important thing, first of all, CAD and person detection model. It also includes face detection and face classification model. And here in the picture, you can see how this system components work. A car and person detection model. So it utilizes ULO V7 object detection algorithm. It also predicts bounding boxes and class probabilities together, and it is trained on diverse data set for accurate detection. And finally, it's optimized for faster inference using ONNX format, which is basically like applying a filter to a picture. Here are some examples for car and person detection model. Let's see, Athirah model arrived. Moving along to face detection. Pre-trained model REST10 based on single shot multi-box detector SSD framework. It's trained on annotated face images, accurately locate and localize faces in the front seat of a car. Why REST10? Why this model? Because it's enhanced system capabilities. It also enables real-time face detection in video streams or static images, and contributes to comprehensive detection and classification of a child passenger. It's also a well-established and widely adopted model in face detection research. Here is an example of how this model also works. This is like a face in the picture in the right. To face classification, it classifies detected face. Okay, so how this facial classification works? It classifies detected face as a children or adults. It also utilizes deep learning based face classification techniques, and it also extracts uh, feature using CNN structures to the data collection for classification. So data set for this model gathered 345 images extracted from a large age gap face verification and 10 face W data set. The first age group was the first age group was 1,829 adult face images. The second age group was gathered 1,216 child face images. Also, the images were scaled to 105 times 105 pixels. Data analysis and results. So the proposed child face classification system was evaluated using a training dataset, 2,624 images, a validation dataset, 254 images, and a testing dataset, 316 images. And the training accuracy of 97%, validation accuracy 95.67%, and testing accuracy 86%. Uh, Here's a video that I explained for the not just the word with the family, it's first as a person and then it's tested as a child. So our system was tested on a real-time video to rate its performing and detecting children in the front seat of the car. Uh, in conclusion, our system proposed child detection system for front seat of a car. It also utilizes YOLO V7 for car and person detection. And it employed VGG16 and CNN model to classify detected faces as children or adults. It also achieved high training accuracy, 97% validation accuracy, also 95.67, and testing accuracy was 86%. It also enhanced safety and well-being of land passengers. Our future work, we aspire to increases data set and apply processing techniques to improve visibility in low light conditions. It also um, integrate to thermal imaging for better detection at night, and it also um, improve accuracy when child face is not clear in the scene. That was my time. Thank you for listening.